Bruno, welcome.
Hello, Alex. Welcome. Thank you for welcoming me.
Of course, of course. Thanks for joining me. So today we have a kind of plain website, a fine website, but we want to kind of show someone how to make it a lot more fun to play with maybe and just make it a bit more punchy. So if I have my own personal site, I want to add a little touch of 3D and wow my visitors. Can you show me how to do that today?
Yeah, that's the idea. Obviously, you can adapt what we are going to do for any website, but right now all we have is just like a title. It can be your portfolio, it can be for a product, for any website you can create, and we are going to add some 3D stuff on that website. It's going to be like really straightforward. We are going to start from nothing, like we just have a title, and we are going to add the library, add some code, and at the end you will see that in just like maybe let's say 30 lines of code, we can have like cool object on the scene and some interaction too.
Awesome. That sounds great. Let's get to it.
So yeah, let's go. First, obviously, we're going to talk about Three.js. So we need to use the Three.js library. There are many ways of adding Three.js. If you're using like a bundler, like, I don't know, Webpack, Snowpack, Rollup, stuff like that, you can use NPM to add Three.js. But if you want to do it like much more simple, you can simply, because we are using CodePen, we can simply add the library. So to add the library, we are going to go to this little, how do you say, options button. Go to the library and search for Three.js, because Three.js can be used like just a build. You just need to add it to your HTML, to your using a script, and you will have access to the library. So I did this one. So currently for us, it's the 125. It might be different, but do not worry if you're doing this. It can be like 26, 126, 27. There are no major changes. The library is very stable, so the code will probably be exactly the same for many months. So now that we have it, we can close this part here, like that. And we can start using it. The first thing to know is that when now that we loaded the Three.js library, we have access to one very specific variable, which is 3, just like that. Okay. To see what's inside this variable, I would just open the console and do a simple console log like this. And if I save, I will be able to see that we have now access to a lot of things. And this is what I like with Three.js, is that every classes that we need are inside that variable. All right, almost every classes. If you go through my course, you will see that some of the classes are not, some very specific classes are not inside that variable. It's for performances like the weight of the library reasons, but most of the classes and all the classes we are going to use right now are inside that variable. Let's say you want to use, I don't know, maybe the ambient light. You will do something like new 3, and here we can see there is the ambient light. So it's 3.ambient light, something like that. Obviously, we are not going to use this one, and we are going to create like the basic stuff we need for a simple scene. As a reminder, we just want to have an object. We will see what we can do, what objects we can add easily with Three.js, but we want our object to be visible here and be able, let's say, just to move the camera around to just see from the side and make the object rotate a little to keep things simple. We need 4 things to start with. First, it's like a movie set. In a movie set, you need the scene, and on the scene, you will add objects. Maybe it can be like characters, and you also need a camera. All right, so let's do that. First, we need a scene. To create a scene, it's as simple as creating a variable. So I'm using a const. Obviously, you can do like let, var, it's not a problem, but I will use a const because it's not going to change. And you do new 3.scene. And you have to do it like that. So it's Pascal case, all right? And we just created our first scene. We can log it. It's not very interesting, but let's just make sure that we are not making any mistake here. And we can see that the scene is being logged right here. We don't need to check inside. So this is kind of an empty scene. On a movie set, obviously, you now need to add objects, to add camera, to add stuff like that. So let's add a camera. So we are going to create a new variable. As always, you can name it as you want. I'm going to use const camera equal new, and you must know that there is different types of camera in Three.js. There is orthographic camera, there is some stereoscopic cameras, but there is also the most like logic camera, which is the perspective camera. It's a camera where things that are far are small and things that are close or big. It's kind of real life camera. So to create this perspective camera, yet again, we just need to do 3.perspective camera like that. This camera needs some options. It's kind of what you can see in real life, because you can have a camera that can see like this, like almost like 180 degrees, or you
Very
can have a camera,
lens.
yeah, wide angle, which kind of do transform distortion on the side, which is if you put like a angle too big. But you can also can have like a a scope with a very small angle, and we'll be able to see very far, something very far. We look a lot bigger.
Telephoto lens.
Exactly.
Cool.
So here we need to provide this angle, and it's in degrees. We can put, I don't know, like usually I start with something like 75 because it's quite large. I do that so that if I put an object a little too far on the side, I will be able to see it. But obviously, if I put the object like behind, I won't be able to see it. So 75 is quite a lot. You can also try like something like 45. It's fine too. Let's try. Let's just try. We put 75 for now, but we can get there later. Then we need to provide what we call an aspect ratio. I won't spend too much time on this one. It's just the width divided by the height. So in our case, we want our WebGL scene to kind of cover the whole background of our website, all right? It can be different. You can have like WebGL just on a small part of your website. Maybe it's just like, I don't know, you want to show your product on the product page, but you don't want it to fill the whole page. We just put it in like a smaller part of the website. But in our case, it's going to be the whole screen. So here it's going to be window inner width, which is this whole width divided by window.inner height. All right, but you can change it. You can put like 800, 600, anything else. All right, so we have our camera. Unfortunately, we cannot see anything yet. We have to add a few more stuff. Do not worry, there is not that much stuff to add. But one thing to understand is that when you have objects can be like a cube, object can be a character, a model you loaded, but also the camera, you have to add those to the scene. So to add something to your scene, you will simply do scene, add camera. And you can add a lot of objects. That doesn't mean we are going to be able to see like a camera, a 3D camera, but this will be kind of the point of view when we will do a render. And it's coming right after. So it's good for now?
Yeah, this is great.
Next part, obviously, it's to add stuff in our scene because we want to be able to see some stuff. We are forgetting something about the camera. We'll get back to it right after. So to add objects, we will start very simple. We will add, let's say, a cube. What's a cube when we are using WebGL, when we are using Three.js? A cube is an object that we will be able to see. An object that we can see is called a mesh. In Three.js, an object we can see is called a mesh. A mesh is composed of two things. It's a geometry. A geometry is like the vertices. It's like points that compose a geometry. If you take a cube, how many points do you have?
9.
No.
6.
It's 8.
Is it 6? 8?
There is 8
That
points
makes
on a
sense.
cube.
That makes sense. We're going to edit that out, right?
Obviously. Put a big 8 on the video. So yeah, obviously it's a geometry. Like if you want to create a cube, it's going to be 8 points. But actually there is more points because 3 points will compose one triangle, and we create like one triangle, another triangle, another triangle, another triangle, and actually there is a lot more vertices because we have to use something like 3 vertices on each corner, so it's much more complex. But do not worry, we can just ask Three.js to create this for us. So we need to create first the geometry that will be composed of vertices, stuff like that. I do explain all of these in the course, but right now we just want our cube in our scene. So let's get a thing fast. We will create that geometry. You can call this like cube geometry or anything else. And we will yet again do 3. So new 3, box geometry. And this is a geometry that will automatically create those points. You don't have to answer the question on how many, where are they supposed to be, how to link them to create triangle. All of this is very complex. We can just create this box geometry and provide some parameters like 1, 1, 1, which are the width, the height, and the depth. All right, so we created the geometry. we can actually just make sure we are not making any mistake. As long as you don't have any error in the console, it's good. We then need so let's remind, we want to create a mesh. A mesh is composed of geometry, but also a material. The material is how the geometry will look once it's in the scene. It can be, I don't know, like a red cube, it can be a white cube, or it can be with textures, or it can react to light, and it can be like a lot of things. For us, we will start very simple with a red cube so that we can be able to see something on the screen. So we are going to create a material, and to just create a color, like a uniform color that doesn't react to light or stuff like that, we need to do new 3.mesh basic material. All of those classes are available inside the documentation. If you're curious, you can just go to 3js.org. You will have access to a documentation, and you will see all the geometries, all the materials, and you can just test them, and you will have also access to many examples. But we created this to provide a color because we want a red cube. We can send an object and decide on a color here. There are many ways of providing a color. You can use like a string looking like that. You can also use hexadecimal looking like that. And you can also use the JavaScript way, which is 0xff0000. All right. All of those will work because Three.js is handling those different formats. So we have our geometry. We have our material. What can we create now?
Our mesh.
The mesh, exactly. We are creating the mesh, so I will call this one mesh. Obviously, you can call it like cube if you want, but mesh is fine. And we do new 3.mesh, kind of obvious. And we provide the geometry and the material. And why should we not forget?
We shouldn't forget to add it to our scene.
Exactly. We need to add the mesh to our scene. Actually, no, it's not why we are not able to see it. It's because we don't have this canvas stuff yet. It's coming, do not worry. So let's hope we didn't do any mistakes. So maybe you can see errors on my console, but it's probably because the code was not finished. So if I just do that and I do some changes, I don't think I will have errors. Great.
We're good. Yeah, we're great.
Okay, last part is getting something visually on our page. It's a little tricky, but do not worry, it's way more simple than if we have done it using a plain like raw WebGL. What we need now is to create a picture of our scene through the point of view of our camera. To do that, we need to create what we call a renderer. To create a renderer, so we create first variable and we assign new 3, and we need to provide a renderer. There are different types of renderer, but usually we just use the default one, which is the one almost everybody uses when using Three.js. It's WebGL renderer. We want to use WebGL, the WebGL JavaScript API to render that scene. So we use WebGL renderer. Let's not forget the ER at the end. And here we will be able to provide more information right after. So our renderer, we need also to provide a size. As we said earlier, we want our WebGL to fill the whole scene so that it's kind of immersive. To do that, we will do renderer set size, and yet again, I will simply use the window inner width and window inner 8 because I want my WebGL to fill the whole thing, all right, to fill the whole page. I think it's done. What we need to do now is draw inside a canvas. Why a canvas? Well, it's because you cannot just draw stuff on the screen like that. You're inside a web page. Where can we draw WebGL? We have to draw WebGL inside a canvas. There are two ways of doing this. First way is by adding the canvas, like that. So you can create one, okay? And then you will have to provide it here. The other solution, if you don't provide a canvas here, the renderer will create one automatically. And when we say set size, it will resize that render. So it's great. We can just let Three.js create the canvas and add this canvas to our page. So let's go. We will let Three.js create that canvas and we will do document. So how to access it? Well, we can just do like a console log to make sure that this canvas exists. And it's in renderer and it's a DOM element, if I'm right. And to test that, I'm going to do that. And yeah, as you can see, we now have a canvas. It's not yet inside the HTML, but it exists because we didn't provide one here. So what we need to do now is add that canvas that Three.js automatically created to our page in order to be able to see something. To do that, we need to do, well, actually we can like add it to the main or to the body. Let's add it to the body. We will do document body, and we can simply do append or append child. It's almost the same thing. And we will do renderer DOM element like that. So we are adding, so this is just like a plain JavaScript. We are just adding the canvas, which is the renderer DOM element, to our body. Let's make sure that it's working. It's supposed to be somewhere over there. Yeah, see? It's right here. We have our canvas. But if you look on the little bubble here, it's not at the right position. It's like below our page. It's because our canvas currently has the right size, which is this size here, because we provided a set size here, but it's below our page. This is just a CSS matter. We need to put that canvas behind our CSS. To do that, well, we can just target it in CSS. We can also like add a class or something like that, but I would just target canvas. Just make sure that you don't have other canvas on the page. They might be how do you say? They might.
There might be a conflict. You might be styling something that you don't mean to be styling.
Exactly. But in our case, we just have this canvas, so we can just do something like that. And we have to put it, so there is multiple ways of putting it behind. I don't know, let's do position, absolute. We can do like top 0. We can do then left 0. And we don't have to provide like the width and the height because we already resized the canvas here. Be careful. If you resize the window, the canvas will not follow. All right, we won't cover this here, but obviously you can just like listen to the resize event and then resize your canvas, stuff like that. But we will not cover this here. Is our canvas at the right place? Yeah. As you can see now, the canvas is right beyond. And actually you can see a difference in the color because by default, the canvas, when you just create a canvas using the renderer, it will be black. Right before we had a color slightly different behind.
Slightly less black, yeah.
Kind of a dark purple. So it means that it's working. We have our canvas here, but we still don't have our cube visible. What we need to do now is do a render. Doing a render is like taking a photo. Like if you are doing like a film, you will take a lot of photos. You will take like one photo every like maybe 30 photos per second. It depends on the frequency you want. We need to do that. But before doing this, like on each frame, we just do one photo because we want to see our cube. So let's go. To do one photo of our scene seen through the camera, we need to do renderer. We are almost there. Render. We need to provide the scene because we can have multiple scenes. Usually we always have one scene, but you can have multiple scenes if you need in your project. And yet again, we can have multiple cameras, but we only have one camera right now. So did I did a mistake? So let's test. I can just save. I will just do like a change to make sure that it's refreshing. There is no error, but I can't see anything. Do you have an idea why?
I do not. I thought maybe... is this not being called? I'm not sure.
The code is good. But we forgot something.
Is the camera right on top of the object? Yeah.
Exactly. We didn't provide any position. We say, I'm creating a camera, I'm creating a cube, and we just like throw it to the scene. By default, every object you add to the scene will be at the center of the scene. So we put a camera at the center of the scene, probably looking in a direction, I don't know which one. And then we also provide like a cube, and it's probably in the middle of the scene. So in a way, we are inside the cube. Should we see like red everywhere? No. By default, you cannot see the, let's say, the inside of the geometries. It's not exactly that. It's more like you can see like a face, but you can't see the other part of the face. So it's more like that. So we are trying to see the inside of the cube, and we cannot see anything because we are inside of the cube. We are looking at the back side of the faces. We can reverse the side, but it's not what we want. What we want is move the camera away from the cube to be able to see that cube. To change objects, and this will work with both meshes, cameras, or any type of object you have in Three.js. You can change the position property. Position is a vector 3, and this is where things get a little harder and we start to talk about 3D stuff. In 3D, you have 3 axes. You have X, Y, and Z. By default in Three.js, X is doing like this truck movement, like that. Y is doing to the top, all right? It's a pedestal, I think we say. And then you have the Z that is going, if I'm right, forward or maybe backward. I have doubt right now. But anyway, it's moving forward or backward. So one of those. So if we want our camera to move back, we need to play with the Z axis. So axis. So we can, I don't know, maybe try +3. Let's see. Nothing. Ah, yeah, it's there.
There we go.
So Z is being positive toward the camera, toward us. Great. So that's a cube, but that cube looks more like a square. It's because we are just perfectly aligned with it, which is why we can only see one face of the cube. Actually, we can try to maybe rotate it a little. To do a rotation, just like we did a position, we just want to rotate it like once. We can do mesh, rotation, and because we want to do this movement like this, it's like if you put a exactly. You put a spike through your object and you try to rotate like this, like a carousel. You just want to do some kind of animation like that. So it's, as you said, on the Y, and you can just provide an angle. And let's see the result, and it's rotated like that.
The 0.5, what's the unit there?
0.5, it's in radians. It's not degrees. If I put 90 like that, it won't do like a quarter of a circle. It's radians. If you use pi, if you remember from high school, pi, you can have access to pi. If I put it like, let's say, in the console right here, you will see that it's 3.14159. You've probably seen this number. It's pi, and this is half a circle. Half a revolution. So every time you need, I don't know, you just want to do 1/8 of a circle, you will do something like math pi divided by 4, because pi is half of a circle. If you want to do an 1/8, it's going to be divided by 4. It's where math can be useful. So if you're bad at math, like me, you will struggle a little before you can find the right value. If you're good at math, great for you. It will be helpful. So yeah, we can actually let the math pi, but anyway, we are going to do like a rotation. First, what I don't like here is that the cube is at the center. I have my title on the left. I want my object to be on the right. We will put another object quite soon, but we just want our camera to move on the left a little. Actually, we could have moved like the object on the right. It's quite the same thing. To move the camera on the left, we can do camera, and yet again, we can use position. And if you remember, which angle is it? If I want to go to the
position.
left.
If I go to the left, that would be X?
X, exactly. X. And we can try, I don't know, maybe 1. We have to wait. It was the opposite. I got this one wrong. -1, let's test. Yeah, that one is great. Obviously, if you have like a responsive website, you will have to test the size of the window, stuff like that, to be able to provide the right value depending on where you want the cube to be. But let's just not talk about resizing the window and keep this layout. All right, that's cool. We can move forward. Next part is about changing the geometry, because this one is a cube. Okay, that's great, but we have access to a lot more geometries. If you go to the Three.js documentation, you will see that there is a lot of geometries you can use. One I really like is the torus knot, just because it's kind of a messy shape with a lot of like round surfaces, and we see that and it will look just great. So to use the torus knot, if you don't know what's a torus knot, you will see like right now, we can just replace our box geometry by torus knot like this. And obviously it's not the same parameters. I would just provide, I think it's kind of the size, the radius of you will see the kind of loops we get. So I would use 0.5. This is the size of the tube, so you're starting to see something there. And then you can add like subdivision. Subdivision is how much vertices you need. So it's kind of hard to see the shape. Do not worry, we'll be able to see more of it right after. Actually, if I just remove the rotation, we'll be able to see a little more of it. I need to change this one. Yeah, see? This is the torus knot. It's kind of a mess, kind of a brainy stuff, geometry.
It's like a
Quite
Celtic
funny.
knot or something like that. It
Yeah.
feels like. Yeah.
But we don't have enough polygons because, as you can see, we can see like a flat parts on the edge. So we can change this by adding more vertices, and we can control the vertices with the two last parameters. I will just like throw numbers like this. It will just be, you will get more vertices. It will just looks better, as you can see.
Much smoother. So we go from like
Yeah.
a low poly feel to like a high smooth
Exactly.
polygon feel.
And if you need more smoothness, you will just add more. Be careful.
Cool.
If you add too much, it will be bad for performances because all of these data are being sent to the GPU, to the computer, and it needs to process everything, even if you're on a smartphone or stuff like that. So it's starting to look great. I think we are too far. We are, the shape is too small. We have many solutions. Like we are in a 3D environment. We can move the camera forward. We can reduce the angle. We can move the object toward the camera. I think I would just like reduce the angle of the camera. Let's see what I get. Yeah, this one is great. So as you can see, I just reduce the angle, like the field of view. Yeah, that's it. The field of view of the camera to 45. 45 is really a great number. You can have a good result. All right, it's looking great. Let's move forward. The geometry is great, but I would like something a little better than this, like a red uniform color.
You can't really see what the shape is truly. It kind of just feels like a flat pretzel, right?
Yeah, because it's like overlapping each part, so it's kind of a mess. We need something else. This is where the materials, where we can change the materials. There are so many materials, including in Three.js, and you can also create your own materials using what we call shaders. And I do explain shaders in the course, but it's something like really huge, really hard, and there is a lot of hours of lesson about this. We are not going to create our own shader right now. We will just use another shader. So this one is great if you just want an uniform color, but we want to use something else. We can also use materials that are reacting to light. Like if you have a light passing by above the scene, you will see that the object will be illuminated differently. It's great, but we will use something even different. We are going to use matcaps, and I love matcaps. It's a really cool techniques to get something on the visible on the geometry. So what are matcaps and how to use them? First, we are going to access a matcap. So it's going to be at this address. I will just write it to be able to access it. Let me check. So it's on my website, Prismic, matcaps 8.png. All right, this is a matcap. And if you want to check it, yeah, like that. This is just a picture, and we will use that picture. It's usually a picture of a sphere. Actually, you can put like anything on it. You can even create your matcap picture using Photoshop. I've done it for some projects. You might get a good result. So we're going to take that picture and just take like pixels, take the color of that pictures in order to be able to colorize this geometry. And it will be done like automatically. It's like we are going to get the same result here. So this picture here, so this texture, this material here on our geometry. So it was kind of a quick explanation, but as always, I do explain a lot slower in the course. So
yeah.
To use this one,
it's kind of like is it kind of like we are baking in the lights and the environment without having to create all those things? We can just apply it and have a quick result.
Yeah, that's it. It's kind of baking lights and shadows inside a texture and using that texture. So I said the word, it's a texture, so we need to load that texture. To load texture in Three.js, we cannot just provide like the URL like this. We need to use what we call a texture loader. So it's a class that will let us load textures, and then we will be able to send that textures to the material. So we are going to do like 3 texture loader. We just need to provide this. And this texture loader will let us load texture. You can just create one texture loader and load as many textures as you want. We just need one texture, so we just call this one texture. Obviously, if you have many textures, you will do like a matcap texture or stuff like that. But in our case, we just have one texture, and we will do texture loader dot load, and we just need to provide the URL that obviously I have not anymore. So it's.
Did you copy it?
Yeah, I just now copy it. So it's this one here. All right, so we did load the texture. Let me check if it's working. Yeah, it seems to be working. I have some errors, but I don't think it's that bad. No error. Strange. Okay, so we have our texture in here. So let's just do a quick recap of what we did. To load a texture, because we need that texture we just saw, we need a texture loader. So we just create a texture loader. This texture loader, we can use it to load as many textures as we want. We just need one texture, it's this one. So we just call texture loader dot load, and we provide the URL of the image we want to load as a texture. Now we have access to this texture. We can use it inside the material I want to show you. First, let's change this mesh basic material to mesh matcap material. And then we can provide the matcap right here. And instead of a color, we are going to provide a texture. This is just the way of writing it. If you don't know about that, you just need to check the example on the Three.js documentation. You will see that you have great examples, and you even have like you can preview the results. So it's the documentation is really useful. But we have a problem here. We cannot see anything. And this one is kind of tricky. The first time you are doing this, you just can't see anything. And it's kind of tricky. It's because we are taking a photo at the beginning. Like we just set stuff, we create our tourist note, we create our material, and we take a picture. But the texture isn't loaded yet. Yes, so we are taking a picture of our object with this material, but the texture is currently like all black because the image isn't loaded yet. What we can do just to make sure of that is wait a little. To do that, I'm going to do like set timeout. I would just wait, I don't know, maybe we can wait like 3 seconds to be really sure that the texture is loaded. And I will do the render in 3 seconds, just to make sure of that. Let's see. So it's working. As you can see, I just asked my JavaScript to wait 3 seconds before showing me the result, before taking the picture. But this is kind of ugly. You want, maybe the user can see the result right now. And anyway, we want to animate stuff. So right now, we are just going to animate stuff. And we see that it's very, very simple. What we need to do is take a picture on each frame. To do this, it has nothing to do with Three.js. It's more like JavaScript. How do you trigger a function on each frame? You will use the request animation frame. So first, I'm going to create a function. I will call it like tick. Why not? This way you get something that do tick, 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 tick on each frame. So I create a function. Obviously, you can create a function any way you want. I like to use fat arrow, but if you want to do like function tick, it's up to you. All right, you will get the same result. Then I will call it once. Just call it once. You create a function, you call it this one. Then I will put the render inside of this function. In a way, right now, I change absolutely nothing. I just move the render inside of a tick function, and then I call this tick function. So we get exactly the same result that we have at the beginning. And what we are going to do right now is use this small line of code, which is window request animation frame. It has nothing to do with Three.js. It's like a classic animation in JavaScript. So request animation frame like that. And I will pass the tick as the parameters, just like that. And I'm going to explain obviously what's happening here. And now it's working. What we did here is that we said that on the next frame, JavaScript has to call this function. And this function will be called on the next frame. And we say on the next frame, call this function. And on the next frame, call this function. And you get something being called on each frame. And that's all. Got it?
Cool. Yeah.
Cool. But how can we make sure that it's working? Well, let's just rotate our object. Obviously, right now you can do so many stuff. You can do better animation, make the camera move forward, stuff like that, like an introduction, change the opacity. You can do so much, but we just want to make sure that the animation is working. We're going to do a rotation, like a carousel, on the object. To do that, we are going to increment the rotation. So we will do mesh. As we did before, rotation, it's on the y-axis, and we just do like plus equal 0. I don't know, maybe 0.01. Let's see the result.
So tick is being called multiple times per second, and each time it's called, it's rotating the mesh just a slight bit, and that's what's giving us that smooth animation.
Yeah, that's exactly it. Be careful. If you have like a screen that runs at a faster frame rate, you will see that the animation is faster too. You need to base the animation on the time, and we do learn how to do that in the course. But for now, it's okay. Maybe it will run faster on a computer with a faster frame rate, but that's the idea. We are calling tick on each frame, and this way we are just incrementing the rotation, and it's looking great. But we are not done yet because we forgot about something. It's that we lost our background. See this one here? We had this background here before. So if I remove, let's say, if I remove my canvas like this, we just wait for the refresh. And you can see that there is like kind of a dark purple background, but by default in Three.js, you get like a black background. There are multiple ways of changing this one. What we can do is say we want a transparent background. This way you can just get back what you had before. To do that, you can, inside the WebGL renderer instantiation here, you can do alpha true. So it's just an object. Maybe I would just make sure it's, yeah, because of the line break, we can't see much. So it's more like this, alpha true. As you can see, now the background is transparent. So if you want to change, let's say, let's put like an ugly red color. As you can see, it's working.
Yeah.
Great. Okay, cool. We have one more last thing to do that we say we are going to do. We want the camera to move because it's already great. You can have your product, you can have something you have modelized inside Blender, Cinema 4D, you can add any object you want here. But it's better like for something more immersive, it's better like to have, I don't know, maybe camera movement or stuff like that. We're going to do like a classic animation. It's going to be quite fast, but you will see that it will just looks great. The idea is that if you move the mouse on the left, the camera will move on the left, and if you move on the right, it will move on the right. Same thing up and down, but this will happen with a slight, like we say, easing. You know, it's going to be smooth. It's not going to be straight following the cursor. It's going to be quite smooth. So to do that, first we need a way to know where is the cursor. So I will not use a mouse because sometimes, you know, you're on on a smartphone, stuff like that. I will call this one, let's say, cursor. So I will create cursor x0, y0, like that. The idea is that I'm creating just an object. I store the x and the y inside that object, and I'm going to update those, so the x and the y, when my mouse is moving through the website. And later, I'm going to use those coordinates to move the camera. So how do we know when the mouse is moving? Yet again, it has nothing to do with Three.js. Right now, we're just doing like a raw JavaScript. We are going to listen to an event, so add event listener, and we are going to listen to the mouse move event, like that. And we provide a function. Again, you can use fat arrow, you can just write function like the classic function. It's up to you, it won't change anything. And here we want to save the position of the cursor. So we're going to do like cursor x equal, and to get the position of the cursor, first we need to put a variable here. I'm going to call this one underscore event. Some people like to do just e or event. It's up to you. You can put anything here. It's really up to you, as long as you use the same variable name inside your function. Me, I'm going to use so underscore event, and here I'm going to put event. It's an object. To access the position of the cursor, I do event client x. I know it was quite fast, but it's because it's like a classic JavaScript. Let's not spend too much time on this one. Then I want to test if it's working, because let's make sure I didn't do any mistake. So let's move the cursor. And as you can see, so we don't have much room here. Yeah, we get the coordinates of the cursor on the X axis, all right? If I'm on the left, it's close to 0. If I'm on the right, it's close to 1,400, something like that. That's great, but this is not the kind of value we want to play with, because those kind of value can change according to the resolution and stuff like that. What I like to do is values that are normalized, meaning it goes from 0 to 1. To get this, I want 0 on the left, I want 1 on the right. I will simply divide by window inner width. Because remember that we want our experience, our WebGL to take the whole screen, so we can just do window inner width. And as you can see, so it's a big number, let's increase this one. If I'm on the left, I'm close to 0. If I'm on the right, I'm really close to 1. It's just better. It has nothing to do with Three.js. When you are handling like complex calculations, complex variables with numbers, stuff like that, if you can have something from 0 to 1, it's great, like a 1 amplitude. And we will go even further. We will do minus 0.5. Why minus 0.5? Well, because you won't see this a lot, but I really like to do that. If you do that, you get a variable that is close to 0 when you're at the center. It will get close to minus 0.5 on the left and close to positive 0.5 to the right. This way you get a variable that has 1 amplitude, but it can be as positive, so as positive as negative. So I like this kind of values. Again, it's up to you. You can do anything with any variable. You can play with trigonometry, stuff like that.
So is that because we want to have the center of the camera be where it is right now, and then we want to shift it either to the left or the right, rather than it starting on the left and moving all the way to the right?
That's exactly that. We are going to use the cursor to position the camera, meaning that if we position the cursor in the center, the cursor X and the cursor Y will be close to 0, so the camera will be at the exact same position. That's the idea. So let's do the same here. So it's going to be cursor Y. This time we are going to use client Y, and we are going to do window inner height this time. And we can just test this one. And I'm doing a mistake right now, but we will see that mistake later. So let's see. I'm going to remove this, and I'm testing. So if I'm at the top, I get minus 0.5. And if I'm at the bottom, I get positive 0.5. And some people might say, this is not good. And that's true. We will see why later. Maybe you have you already found it?
No, I have not, but I'm curious.
You will see.
I'm excited to say.
But that's a good start anyway, so let's move forward on this one. So what we can do right now is just move the camera. We have been like writing a lot of codes. I know if it was quite long and quite complex. We want to see the result. We are not going to do like the smooth easing right away. We just want to move the camera. So we will do camera dot position. Let's save it inside a variable. It's going to be a little more simple. You will see why. So camera X equal cursor X, and then camera Y equal cursor Y. It might look strange, but I'm going to add a little more here, which is why I like to have variable for those. So these are just variables containing the cursor X and cursor Y, which is strange, but you will see why we are doing that right after. Then we can just update the camera, and to move object in Three.js, we already saw that, we need to play with the position. And we can change the position X by doing camera X. So right now it's following the cursor, but we have two problems. First, it's only on the X axis, so we need to add the Y axis. But also we lost like the slight offset we did, like moving the camera slightly on the left. So we can fix that right now. So was it +1 or -1? Maybe it was -1. I already forgot. So let's try -1. Yeah, that's it. See, I just changed slightly offset the camera X by doing -1. This way it's always on the right a little, so the camera is a little on the left. So it's working. Let's add the Y. So I'm going to do camera position Y equal camera Y. All right, so as you can see, there is some kind of problem. Like it's working, we can move up and down. But as you can see, if I move like this, I have something strange happening. And if I move like this, I have something strange too. Let's try to refresh. Maybe I got something wrong. So if I move, come on. If I move the camera, the cursor on the left, it looks like the camera is moving on the left. And if I move the cursor on the right, the camera is going on the right. But if I move up and down, look, if I move up, the camera is going down. And if I move down, the camera is going up. This is where we have a problem. What we did here was quite a mistake. And it's not much of our fault. It's a classic problem. The problem is that event client X is being positive when going down, but in Three.js, the y-axis is positive when going up by default. Okay. Yeah, it could have been very differently made, like y could have been positive when going down, but usually y is being positive when going up. It depends on the software, stuff like that, where actually, like in Blender, it's not y going up, it's z. Right. Yeah, which is kind of a debate.
It's confusing going from one to the other, for sure.
Yeah, it's always a mess, but yeah, it's just arbitrary axis. It can be anything actually. So to fix that, what we can do is simply put a minus here. All right, we could have changed the cursor, but I like to keep the cursor as it is. Like it's the cursor position using, it's kind of the CSS unit, so it's y being positive when going down, and I just like invert it when I want to use it inside Three.js. And as you can see, it's working great. And we have our camera moving. This way we can just enjoy, it's more immersive, we can enjoy our model. But as said that I wanted something more smooth, we're going to kind of ease the animation, all right? To do that, I'm going to use the famous ease animation, which is famous, but always kind of hard to explain. The idea is that we are going to move the X toward the destination, but not straight to the destination. We are going to move, let's say, 1/10 of the destination. So my camera is there. This is where the camera is supposed to be. I'm not going to move the camera there. I'm going to move it like 1/10 of the distance. On the next frame, I'm going to move 1/10 and 1/10 and 1/10 and again and again and again. As you can see, it's getting smaller. And if my cursor move, then the camera is supposed to be here. It will do something like that and get closer and get closer and get closer. This is the ease, the kind of the classic ease animation that will just make things, old animation, smooth. All right, we need to get closer than the destination. Regardless of the destination, if it's there, we will get closer and closer, and always like the same proportion, like 1/10. It can be 1/20th or anything like that.
Does it never actually get there?
Exactly, you never get there.
Okay.
Yeah.
But it becomes so small that you can't tell.
Yeah, that's it. When it's less than 1 pixel, you won't see a difference.
Right.
To do that, we will just start with the position X. Yeah, let's just focus on the X. So I will do position X, and I'm going to add 1/10 of the delta. So I will calculate like the difference between the actual position and the destination, and add 1/10 of this. So I just command the tick function so we don't get an error while doing this. So I will do camera, so it's going to be position X plus equal. We need the difference between the actual position and the destination. So it's going to be camera X minus camera position X. So this is the delta, the difference between the current position and the destination. And we are going to divide it by, let's say, 10. So it's 1/10. So we add 1/10 of the delta between the position. So we can now test it like that. And look at that. See how smooth?
Yeah, that's great.
And we can do exactly the same for the Y. So let's go. Camera position Y. Camera Y, position Y. So exactly the same. I just changed to a Y like that. And I got exactly the same result like this. It just feels more immersive, more smooth. And if you want like something really smooth, you can just change this one. I don't know, maybe put like 50. Let's test this.
Oh,
and see, it's
so it's
way
a lot
too
longer to
Exactly.
move. So it's kind of, this is almost like it gives you like a you're floating in space kind of feeling, where the other one's a lot
Yeah.
more quick, a lot more responsive.
Yeah, you need something quite responsive if you want to feel to have a good feeling. But if you want to do something in space or in the water, just lower it and it will just do fine. And if you want like to be almost like instant, see, it looks like
Yeah,
it's
that's very
very
fast.
fast, but it's not. It's just it feels smooth like that.
Right.
Okay, I think we're done. I would just put back 1/10 like this, and that's all.
That's great. This is such a cool effect. And if you're following this at home, you don't have to go with the torus knot and with this matcap. You can go ahead and get any cool shape from the Three.js library. Or as Bruno said, you can get any kind of object and import that. That'd be a different lesson, but there are a ton of cool matcaps, so we can show them on the screen here. There's a ton of cool matcaps that you can pick one, add it to your shape, and you're going to get a really cool result. And with these awesome camera responsive effects, your homepage is going to stand out compared to everyone else's. So this is so cool. Bruno, thank you so much for showing us this.
Thanks to you.
This is a great effect. So yeah, thank you so much. So this was just a taste of Three.js. If you want to learn Three.js from absolute beginning to, man, he goes through shaders, he goes through everything you can possibly want to learn about Three.js. Go sign up for Three.js Journey. It's at threejsjourney.xyz. We'll have a link in the description. Bruno, thank you so much.
Yeah, thanks to you. Obviously, you can add like a lot more. You can handle the resize, you can add particles, you can create your own models. By the way, in my course, Three.js Journey, you will also learn how to use Blender to create your own models. Anyway, yeah, that was just great. It was a really cool example. I hope you like it, and thank you, Alex.
Yeah, and we're going to include the link to this in the description, so you can go ahead and check out the code, change it however you want. It is yours to use. So thanks again. Have a good one.
Bye.